So now we will understand how do we represent the intermediate code. Okay. So there are so many ways to represent this intermediate code. One of the form is by using the postfix notation. So another form is by using the syntax trees. So there are so many ways to represent this intermediate code. So actually in the while explaining the lab program, I told you why we have to go for intermediate representation. I hope you people are remembering the diagram where you have taken the four source languages and 3 computers. Okay, when you don't have an intermediate representation, whatever the program you have written in each source program has to be converted into the individual systems, right? But if you have a code generator, only single copy of that code what you have written in 4 languages will be, it will be that means all the 4 languages copy will be converted into one intermediate code, and that same intermediate code can run on the different machines. Okay, so as I told you, there are so many ways to represent this intermediate code. So one of the way here is by using the postfix notation. So what do you mean by postfix notation? How do you write postfix notation? Can you give simple example?
AB plus, ma'am.
Yeah, after the operands you will have the operator, so that is called as postfix notation. So next, another representation of that means, as I told you, there are so many ways to represent this intermediate code. So one of the way is by using the postfix notation. Other ways are, according to your syllabus, the syntax trees, okay, and the 3 address code. Okay, first you will understand what is 3 address code, then you will go for understanding how do we write the syntax tree for the given input. Okay, first we'll see an example for 3 address code. So here we are representing the intermediate code by using the 3 address code. So as I told you in the lab program, so in the 3 address code we will be having a 3 operands. Okay, on the right hand side you will be having maximum 2 operands with at most 1 operator. Okay, and left hand side will be the assignment one. If I'm writing a is equals to b plus c, so a is equals to b plus c. So on the right hand side at most we have 2 operands and 1 operator. Then we can say that it is going to become the 3 address code. That means at most we can have 2 operands and 1 operator on the right hand side of the expression. So that is called as 3 address code. So, okay. So now we can represent this 3 address code in different ways. Okay, I will explain this syntax tree later. What is DAG, direct acyclic graph? Before that we'll go for what is 3 address code and how do we represent. Okay, so in this 3 address code we have different types of instructions. So what are the instructions we have? Suppose if I write x is equals to y. Okay, x is equals to y operator z. That means what is the general expression we have? If I have x is equals to y operator z, that means here we are having 2 operands y and z, and you will be having 1 operator. Okay, that means at most you can have only one operator and 2 operands on the right hand side of the expression. Okay, then you consider this one, x is equals to op y. That means you are having a operator. When you have a operator, only one operator, followed by one operand, then generally we say that we are going for unary operators, like for representing minus 5 or for minus b. That means you are representing unary operator here. Then if I write an instruction x is equals to y, then it will copy the contents of y onto the x. Okay, that means we can write an 3 address code for assignment operators and for unary operators, and also for if I'm writing x is equals to y, then it is going to become the copy instruction. Then how do we represent the 3 address code for unconditional jump? That is, you have to use an instruction called go to L. That means L will be indicating a label. Then you can also have a conditional jump instruction. One by one you will understand. So now I will start with the simple 3 address code. Okay, shall I explain here in the PDF directly or shall I write in the Word document? Shall I use the whiteboard, or if I'm writing here, is it sufficient? Respond. Shall I explain here only? Are you able to see this PDF?
Yes, ma'am.
Yeah. So consider this expression. Statement is equals to statement is equals to A is equals to B star minus C. Okay, B star minus C. So this minus C. It is an unary operator, right? That means you are indicating the sign of C plus B star minus C. So that means this is the high level language statement we have. For this one, now you have to represent the intermediate code. Then how do you represent the intermediate code? When we are using the intermediate code, we will store the instructions. Okay, we will store the instructions. We will divide the instructions and we will store it in a temporary variable. See here, you have this one, B star minus C. Here also you have B star minus C. So which one has to be evaluated first? B star minus C. That is the first one. That means first you have this minus C, right? You plus is, the C is having the sign. So what you do means you write the intermediate code. So how do you write intermediate code? First you take this minus C and store it in a temporary variable. So you write T1 is equals to minus C. Observe this statement. So observe this one now. T1 is equals to minus C. Why it is T1 is equals to minus C? We have this minus C no in the expression. So we are storing it in a temporary variable T1. Okay. Then you go for multiplication of B star minus C. Then you take B, okay, star. Then minus C is stored in T1. So you write it as B star T1. And result we are storing it in a temporary variable T2. Okay, then again what you have to do, again you have to perform B star minus C, right? But what you will do, you will store this minus C onto the temporary variable T3. So you write T3 is equals to minus C. That means now we are storing this minus C onto the variable T3. Then you multiply. So then you take this part B star minus C, what we have on the right hand side, complete rightmost expression. So you write B star, okay, you take it as T3 in which you have stored the minus C. Okay, you can observe in the T1 also we are storing the minus C, and in T3 also we are storing the minus 3. Okay, once the intermediate code is generated, you have a code optimizer. There it will reduce the code. Now what the compiler will do, the intermediate code generator, it just goes on writing the code. But when we have a code optimizer, there it will try to reduce. That you will be seeing in the next, how we can avoid this T3. So now in the T4 we have B star T3. That means T3 is nothing but minus C. So that result is stored in the T4. Okay, now we have performed B star minus C and B star minus C. Multiplication is over. You have to perform the plus operation. We know that when we have multiplied first time, the result is stored in the T2, and when we multiply the second time, B star minus 4, it is stored in the T4. So you take T2 plus T4, add T2 and T4 and temporarily store it in the variable T5. Okay, now the result is in T5. So what you have to do, according to the expression, you have to store it in A. So you write A is equals to 15. Okay, so that means this part what you have, it is the intermediate code for this one. Okay, now we have written the 3 address code here. So you can observe here, at most on the right hand side you have only one operator. You don't have more than one operator. That means we have represented this 3 address code for this expression. A is equals to B star minus C plus B star minus C. Is this clear?
Yes, ma'am.
Yeah. So now once we write this intermediate code, we can represent this 3 address code, okay, in by using so many methods. One is triples and one is quadruples. Okay, so I'm repeating, this is one of the important question. So once we write the 3 address code, we can write this 3 address code by using triples and as well as quadruples. So first we'll see an example how we can write for the triples. Okay, see here you have in the triples, sorry, first we'll go for quadruples, later we'll go for triples. If you are understanding quadruples, it will be easy. So as the name itself is indicating, it is quadruples. That means you will be having 4 elements. So which are those 4 elements? You take it as, you observe this first table from the left hand side. Okay, see you have operator, then argument 1, argument 2 and the result. These 4 parameters you consider when you have a quadruples. Okay, so now you have written no, t1 is equals to minus c, t2 is equals to b star t1. That means for this intermediate code, 3 address code, you have to write the quadruples and the triples. Okay, first observe this one, t1 is equals to minus c. Okay, what is the operator here? It is the minus operator. It is the unary operator. So in the operator column you write minus. Okay, in the operator column you write minus. Okay, then what is the first argument? You have only one argument, that is you have only one operand, that is nothing but c. So that c you write under the argument 1 column. Okay, then argument 2 column is empty. Why? Because in this t1 is equals to minus c, you don't have 2 operands, you have only one operand, that is c. So that you write under the argument 1 column. So argument 2 you keep it empty. Okay, I am explaining this first row in this table on the left hand side, what you are observing. Then result minus c, where we are storing? We are storing it in t1. So under the result column you write t1. Okay, so that means for this t1 is equals to minus c, we have represented this by using the quadruples. Okay, so next observe t2 is equals to b star t1. So on the first you have to observe on the right hand side of the 3 address code. See what we have, b star t1. What is the operator? Star. So you write that star under the operator column. ಆಯ್ತಾ ಮ್ಯಾಮ್ ಮೀಟಿಂಗು? Okay, so you write the star under the operator column. Next, how many operands we have in this one? 2 or 1? In this t2 is equals to b star t1. How many operands we have? 2. One is b, another one is t1. So you write b under the argument 1 column, and t2, that is nothing but the second argument, that is nothing but the second operand. So you write that under the argument 2. Okay, then where exactly the result is stored? It is stored in the t2. So under the result column you write t2. Then you consider this t3 is equals to minus c. So same thing, operator is minus c, so you write under the minus column, sorry, you write under the operator column this minus. Then what is the operand we have? Only one, that is c. So you write under the argument 1 column, this one. Okay, then t3 is the destination. Okay, t3 is the destination or the result. So you write the t3 under the result column. Is this clear? Take down this one.